Today we have a question like this. An electric field given by E equal to 4I plus 3 multiplied by y square plus 2 into j passed Gaussian cube of a side 1 meter placed at origin such that its three sides represents x, y and z axis. The net charge enclosed within the cube is okay. So by using the given data, that is E equal to, right? So E equal to what we are having? E equal to, it is 4I plus 3 multiplied by y square plus 2. It is then multiplied by j. Okay. So I and j only gives you the direction. Okay. So now what I do is I simply split this vector into its components like Ex, which is along x axis, and it is Ey, which is along the y axis. I'm not having any z component, right? So because I'm not seeing any k vector. Okay, so it means what? It means Ex, right? So what I can do is Ex is simply 4I. Okay, so this is a in magnitude, constant in magnitude, right? Constant in magnitude, which means if you are having a cube, say how is our cube? Let us draw one thing. So we shall do one thing. We shall simply draw a cube like this. Okay, so this is our cube whose origin is at one of the vertex, right? So this is how our cube looking like. Okay, I choose this one as the origin. This one is the origin. Say it is A, okay, B, C, D, and this is my E, F, right? So this is my G, and this is H. Fine. Now where I should draw where I should draw the axis, right? So I should have the axis like this. This is my x-axis, and this is my y-axis, and this is my z-axis. Now choosing all these the axes into consideration, right? So now what I do is observe the two faces. One is which one? One is this one. So this is what it is actually. It is E, A, right? So D and H. Okay. So this is the horizontal electric field Ex, which is looking like piercing these two sides, which is F, B, C, and G. Ex, which is constant in magnitude, right? So which is in, and this one is out. Okay, but so what you are observing? You are observing since it is a constant in magnitude, right? So Ex, which is Ex in is equal in magnitude to Ex out, as well as the direction, as well as the direction. Therefore, the net flux contributed by this horizontal electric field is null. Okay, so conclusion is what I can conclude. Conclusion is Ex will not contribute. Okay, will not contribute anything. Contribute anything to our calculation. To our calculation. Right. So forget it. Okay, so forget Ex. get x, and think about only ey, ey. Okay. So what actually this ey is? Let me change the color. Okay. So let me change the color. Something I need some better one. Say this one. now, now ey. So what is our ey? Ey is 3 times y square plus 2j. Okay, it is 3y plus, I mean 3 into y square plus 2 into j. Okay, so but this is a function of y. This is a function of y. Okay, so as the y coordinate changes, the magnitude of ey also changes, right? So as y coordinates, y coordinate changes, the value of y, right, changes, magnitude of ey vector also changes. This is the conclusion what I can write here. Okay, so further what I do is I simply bother about the magnitude of ey. So now think about the bottom surface, this one, and the top surface, only these two. Okay, it is a b c d and e f g h, only those two. So let me consider the bottom surface here. This one is the bottom surface. This one is A, B, C, D, through which our EY in. Okay, so EY in is piercing, and at the top we are having one more surface. So what the surface is? It is E, F, G, and H. This is the top surface. Okay, so and here we are having EY out, EY out. Right. So the value of y for this surface is 0, and since the side is 1 meter, it is 1 meter, right? The value of y for this is 1, for this surface, the value of y is 1. Hence, what I can do is, hence, ey in, right? Ey in is of magnitude, okay? Is of magnitude. What I can write? It is 3 multiplied by 0 plus 2. So this is simply 6 units. This is in, and what about ey out? Out. So the flux which is going out is from this top surface, right? So for this, the value of y is 1. So this is 3 plus 1, and it is 9 units. 9 units. Okay. So now I got the net field, right? So the net flux is found. That means we can easily find the net flux because some electric field is emanating from this surface, the top surface. Okay, the flux is negative for the bottom surface and positive for the upper surface. We are having different units, different values. Right. So now what I do is use the net flux, net electric flux, net electric flux. So that is phi equal to what I can write. It is 6 units. I mean 9 units minus 6 units. Right. So into A, into A. Okay. So the dot product, that is cos theta, becomes 1 because the electric field is along the area vector, is area vector, right? So any of the area, so that you choose upper or bottom. So the electric field vector and the area vector are acting in same direction. So theta becomes 0 and hence cos theta is definitely 1. So we can neglect the presence of cos theta in the definition of electric flux. So further what I can write? So flux is equal to, right, it is 3 units into A is 1 meter square because all the sides are 1 meter, right. So 1 into 1 is 1. So area is 1 meter square, is 1 meter square. Okay. So this is simply 3 units. Okay. But what it is asked, we have to find out the charge, the net charge enclosed within the cube, right. So we need the net charge enclosed within the cube. For that, what we have to do? We have to use Gauss law, right. So Gauss law says the net flux through the surface is closed surface is always phi equal to, why it is closed? Of course, we are considering all the surfaces. The net flux is only through the upper and bottom surface, and from the side surfaces are 0. So okay. So anyhow, this is a closed package. So phi is equal to, so what I can say, it is 3 units. Otherwise Gauss law says me 1 divided by epsilon O into q in. So what actually this q in? Q in is the charge which is lying inside the cube. Okay, somewhere here inside we are having some charge which is q in. So that is to be found. Fine. So this phi is 3 units. So on right hand side I am having 1 by epsilon O into q in. So simplify this and you will get q in, and this q in is 3 times epsilon O. Okay. So these many units of charges are inside the cube. This is your answer. So finally what we can choose is, we can choose option B as our final answer.